Hi guys, welcome to my channel. In this video we are going to solve a questions about the water resources engineering, and the chapter will be irrigated drainage. So let's solve the question. The first, we are going to read it and understand what it says to us. In an irrigation project with the time is 12 days, a subsurface drainage problem is observed. Determine the values of the required depth and spacing of the drains to be placed for the following information. An impervious layer is detected at 11 meters below the ground surface. The depth of the root zone is 1.3 meter, and the maximum elevation of the groundwater table relative to the axis of the drain is 0.8 meter. It is assumed that the drains are installed will cause the lowering of the groundwater table 50 centimeter during the irrigation frequency. Now we can see it is the unsteady state case, so we are going to write something like this. Let's check. Yeah, HO will be equal to delta H plus HT. So now HO is 0.8. HO is 0.8, you can see. And the lowering will be 50 centimeters. So delta H, this lowering will be 50 centimeters, is delta H 0.5 and plus HT. And HT is equal to 0.3 meter. Now we obtain the HT and delta H. What is that? So, and now we are going to write the formulation of unsteady state case. Okay, it's going to be Glover equation. L equal to pi multiplied, multiplied K, T, dE, the equivalent depth, over mu, okay, and multiplied ln 1.16 multiplied HO over HT, and this will be 1 over 2. So now the formulation is this. Okay, we are going to write its all data is given inside here, and we are going to make trial and errors, and we are going to determine the depth. Okay, sorry, this length, the length between the two drains. Okay, and now we obtain the depth. I'm going to show you here. We obtain the depth. If this is from that point to until here is 0.8, and this is 1.3 meter, and that is 0.8 meter. So that means that the drains are located 2.1 meter from the ground surface. Okay, so now actually we determine the location of the drains. So let's determine the length of between the two drains. For here, look at here, if you want to use this formulation, we need to find the equivalent depth also. And the formulation of equivalent depth, we are going to assume a length. So we are going to assume a length, and from that length, we are going to determine the equivalent depth. So first, let's write all this data into this formulation, and we are going to get something to assume. So for now, pi multiplied, what is K? 1. What is T? 12. And dE, we don't know it. So, and we divided 0.05 multiplied ln 1.16 multiplied HO. What is HO? HO is here. You can look at here. It's 0.8. 0.8 over HT is 0.3. Okay, and this will be 1 over 2. Yeah. From here, we are going to obtain this value, 45.8 square root of D. Okay. Now this is the length. Okay, this is the length, but we are going to use this as a formulation to obtain the exact length. Okay, so let's do it. For example, now we are going to calculate the equivalent depth. The formulation, I guess you remember, but I'm going to write it here again. d over L multiplied 2.55 ln d over R0 and minus C. And now let's write the formulation of C also. 3.55 minus 1.6 multiplied d over L and plus 2 multiplied d over L square. Okay, now this is the formulation of also C, and we are going to write here as assumptions. Assume L, and we are going to need a d over L value, and of course the equivalent depth and the exact length that we need. Okay, so now in this formulation we are gonna for example assume as 100 as the length. Okay, the d over L, what is d? Let's check what is d. If until that point it is d, yeah, the small d is equal to 2.1, so and this whole is 11 meter, so this is going to be 7.9 meter, I guess. Yeah, from d over L value we are going to obtain 0.089, and from that when I write its own place and rewrite this equation, I'm going to obtain the DE, the equivalent depth, 5.19. Okay, I'm just going to write this value into this here, and I know D, and also R0, and the value of C will be calculated from here, and we are going to obtain a new L, exact L value, 45 square root of dA. When we write its own place, and we are going to obtain 104.4 meter. This is going to be the length, the exact length due to 100. So now you can see it's not close to each other. So we are going to write as 105. And for 105, d over L value will be equal to 0.084. Okay. And due to this value, when we obtain the C and we write the C its own place, and we are going to obtain the equivalent depth as 5.31. Okay, and now you know that this is the formulation of L. When you write the equivalent depth in its own place, and we are going to obtain the exact L value. So we write the 105 and we obtain 105.5 meter. Now this is the length. So now you can see we got too close to each other, 105 and 105.5. So we can accept it. It's okay because it's just hand calculation. When you make with the computers, also it's going to give you a better result. So now the question is solved. Thank you for watching. If you like this video, if you want to see more of the videos, please subscribe and share with your friends. If I did anything wrong, please warn me. See you for the next question.